Okay, so we're going to talk about another rule involving subderivations, the rule of negation introduction. Now, this is a pattern of reasoning that's a little bit more rare outside of formal logic, but it's an extremely useful one. Basically, the way that this kind of reasoning works is that we make an assumption which is the opposite of what it is that we're trying to prove. Now, why would we do that? We're going to make that assumption and show that some consequence of that assumption clashes with something else that's already in our derivation that we've already established, either because we assumed it, it's one of the primary assumptions, one of the premises that we're starting our derivation with, or it's one of the consequences of those. So we're going to assume the opposite of what it is that we're trying to derive. We're going to show that it gets us into trouble somehow. And what that establishes is that that cannot be true. The assumption that got us into trouble has to get tossed out, so we could write it with a negation sign. Let's take a look at an example here. So the premise of this argument is f is equivalent to not g and h. And we're trying to show that this conclusion, not f and g, follows from this. Now, this is an example of a case where negation introduction or negation, one of the negation rules is the only way you can go. If you don't see any other way to proceed, the only thing you can really do is to assume the opposite of what it is you're trying to prove. This is called like a reductio proof or an indirect proof, and often it's the only way that you have to proceed. But let's go ahead and assume the opposite, or assume the negation of what it is that we're trying to prove here. And the opposite of this is, the opposite of not f and g is just f and g. Okay, so this is an assumption for the purposes of negation introduction, because we're trying to show that this is going to lead to some kind of problem. It's going to lead to a case where we have a contradiction, we have a clash between what's in here and what we already have in the proof, and that's going to justify us in saying that this cannot be true. In other words, that this is true. So what should we do here? Well, I think we should probably take this apart first of all and see if we can do anything with FRG by itself. Well, if we have F, which we're getting by conjunction elimination on line 2, then we can get this because F is equivalent to not G and H. So once again, we can reach out of the box. We just can't go back into it once we're done with it. But we have not G and H, so now we can get a contradiction here. So why did I wait till now to get the G out? Well, we want the letters that contradict each other, or whatever it is that we're getting the contradiction from, to go together, to be one after the other. And that's a requirement in this textbook, and it makes the proof much easier to follow if you can see directly where the contradiction's coming from. So we have G, and we're going to go ahead and get not G from this line. So now we have the contradiction. We have a clash here. So we have G and not G. So we know that this cannot be true because it led to a contradiction. It led to something that can't be right. So remember the truth tables. There's no truth value assignment. There's no model of the world or the way the world could be where you have both G and not G. So that can't be right. And if this results in this, then this must be wrong as well. So we can get this. By negation introduction, lines 2 to 6.